Hello, everyone, and welcome to this session titled DataPrepOps, the last frontier of MLOps. Today, we have with us our guest speaker, Jennifer Prendki. She is the founder and CEO of Alectio. Jennifer has an impressive professional experience. Before founding Alectio, she worked as a VP of Machine Learning at Figure 8, Chief Data Scientist at Atlassian, and Senior Manager of Data Science at Walmart Labs. Jennifer is also passionate about fostering a data-driven culture at the work environments, and she is particularly skilled at building and scaling high-performance machine learning teams. Last but not least important, she has a PhD in particle physics from Sorbonne University and enjoys speaking at conferences and motivating women to pursue careers in STEAM. So without further details, let's hear Jennifer's presentation.
Thank you for the kind introduction, and good morning or good afternoon, depending on where you're joining us from. So it's my pleasure to be here today. So today I'd like to discuss a topic that's very important to what I'm doing today, but also something that was very critical, like in different phases of my career. So I will try to make this topic, which is usually considered as a little bit boring or on the boring side, as something that can be a lot more exciting. So quickly about myself. So I mean, even though I have a little bit of an unusual career, like coming from particle physics, like in many ways, my career will be similar to what many of the people attending this talk today are going to experience, right? I mean, and so eventually, like the core point of my career was data prep was a nightmare in my career, and that was both as an IC, an individual contributor, and a data scientist, but also as a manager, because in many circumstances, we had sometimes not enough data, sometimes too much data, and then obviously preparing data was something that was always very slow, very expensive, and I had to deal with many data scientists reporting to me over my career who didn't necessarily have the means, or basically always asking me for more resources, more compute, more data, and better means to prepare this data. So basically, eventually, I decided to look at the problem a little bit more in depth and try to find solution for it. So before we can talk about what data prep ops actually is, I sometimes like to take a step back and sort of go through the history of machine learning, because I think this is really important to try to understand how we've come to where we are today and where eventually all of this is going, right? And so if there is one thing that can help us understand the history of machine learning and basically how we came to having all of these amazing machine learning applications today, it's the history of deep learning. So this is something that very few people, even experts in machine learning, really realize nowadays, right? I mean, so if you look at the history of deep learning, basically it's actually very old. And it's been 70 years that basically the fundamentals of deep learning, or at least the math of deep learning, have been around, right? And so you look at the development of deep learning, and so it's something that's sort of unfolded in an incremental way, right? I mean, so between the 50s and the 80s of the last century, right? I mean, basically you had great scientists discover and develop neural networks, backprop in the same shape that we're using it today, right? And so you have this also interestingly, you have this a succession of phases. Each one of these phases sort of separated by something we call an AI winter. An AI winter is basically a period of time where people sort of give up on AI and basically the belief that everything can be automated. And most of these phases are due to the fact that some other aspect of science wasn't necessarily following at the same pace, right? So basically the second phase was boosted, basically something that happened in the 90s, where eventually we were able to start proving that deep learning was actually something that could function in the real world. And then this is becoming closer to like the nowadays like times and so forth. So like in the last decade, we started having like this massive development of like deep learning applications. This is when we started like reaching the point where we could like pass the Turing test and so forth and so on, right? And eventually like basically like nowadays we're sort of in this phase of like massive adoption of deep learning, right? And so again, like if you look at all of this, it's just like you have this like fast expansion phases, like separated by this sort of like AI winter periods, right? How did we get eventually to the point where we're at today? Well, actually, there's no secret. It's basically like because we suddenly were able to like capture a lot of data and to prepare a lot of data, right? I mean, so to some extent, like the coming to like a maturation of ImageNet basically like was sort of like the turning point for computer vision, and that basically like came through because we have this massive like development of technology, right? I mean, so suddenly like we data scientists started having access to cloud compute, to GPU machines, and so forth and so on. And so what was not possible, or what was only possible, like theoretically speaking, in the 50s, suddenly became like something that we could actually do because we had computers powerful enough to like process all of the basically collect all of the data, store all of the data, and basically manage all of the calculations like necessary for deep learning, right? I mean, so our history as an industry was really dependent of like the maturation of the hardware space and eventually the data space as well. So everything is very exciting, right? I mean, like I'm like any of us here, like I'm very excited about like the coming to maturation of like new sorts of models, GANs, like lots of like cool new applications to AI. But I'm also worried by something that we are all seeing in the press out there. A lot of companies are not happy with what they're seeing, right? I mean, and so this should be of major concern to basically a lot of people and to pretty much all of us, because even though we can like reach like amazing and do amazing things from a technology standpoint, if the people who are funding us are not happy with what they see and they don't really see a return on investment, eventually we're at risk of seeing the next AI winter. And that time it won't be because the technology isn't there, but because like we're not like from a business standpoint, we're not viable, right? And so when you look at basically what's happening in the ML space right now, like technically we have like really great technology, like the hardware has caught up with the software, and that's why we're able to do really great things. But in order to be successful, we also need to have like supportive organizations, which is not necessarily always the case, and we need to have like efficient operations, right? And so these two things are like critical pieces like we need to put in place in order to be able to reach the next level of in machine learning and basically like develop like better, faster, more efficient applications, right? And so supportive organizations like basically something that obviously like is more like a people-centric, is probably going to take some time to get there. Fortunately, more and more organizations are getting there, and then better operations is basically the reason why MLOps exists nowadays, right? So just to take a step back on one of the things I just said, basically like one of the very important points that we need to acknowledge today is that technical viability of machine learning model doesn't need business viability, and this is really putting us at risk from a business standpoint, right? Now, when you look at the development of machine learning ops over the next couple of years, this is really truly what helped us reach the point where we were able to build like amazing machine learning models to the point where these machine learning models could be put in production and eventually like yield a return for our organizations, right? I mean, so basically like was a very important step into like basically like getting things going and basically like really starting to see a return on investment, right? Yeah, I mean, so basically I've been like working for many organizations where back in the days we were able to build like great models, but nobody really knew how to basically like engineer a process that would basically allow us to deploy this efficiently in a production system, right? And so and this is basically the problem that traditional MLOps basically got us to solve, right? Where I think ML, like DataPrepOps, which we're going to talk about, right? I mean, is really helping us is basically like bridge the next gap, which I think is actually more major, where even if you have or you're capable of having a machine learning model into production, if eventually like retraining this model costs you like too much storage, like if data acquisition is too expensive and so forth and so on, it doesn't matter how easy it is to push something in production if like eventually like we're not able to operationalize data preparation, we're basically like not going to reach the point where there is like an actually like a increase in adoption at the industry scale, right? So before we talk about DataPrepOps, let's talk about data prep really quickly, right? And so what is data preparation? The very first answer is like, it's something that people find to be very boring, right? I mean, so basically there's no question that if you ask like somebody who's excited about machine learning, usually they're not super excited about like the part that consists into preparing that data. And so it's almost like a curse or something you need to do, right? So fundamentally, like data preparation is like the act of like manipulating raw data so that it becomes a training data set, right? And so basically there are many different parts in this. And so one of the problems I see in the industry nowadays, right? And it's like, I come from a labeling company. I worked for a labeling company before. And so the labeling companies out there like usually have like pushed forward too much the fact that data preparation was limited to data labeling, right? And so as we know, like data labeling is like a traditionally like fairly like a not technology driven space, right? In reality, getting the right training data set goes way beyond data labeling. In fact, like even though like marketing teams in labeling companies state like you just need to like label your data the right way and you're good to go, that's absolutely not true, because if your data is not good to start with in the first place, you can label it the best way possible. You're not going to get there, right? And so there are actually many more pieces to data preparation than just like data labeling. You have to validate the data, you have to collect the data, you have to find what is the right process to collect data, and you have to know where you need to store this data and so forth and so on. And so basically there are many pieces which, as you'll see later, basically like is an entire field on its own, right? So I mean, basically, like as I said, like basically, like data labeling is just like the tip of the iceberg of everything you need to do if you want to like convert like an unsupervised or an unstructured data set into a structured data set, right? And so there are lots of different pieces that need to come into play. One of the major pieces that we're working on in particular is basically like the selection of data that truly yields value in a data set. But there are many other pieces that different sort of companies basically need to cover, right? And so it's actually pretty complicated when you look at it, and there are like many different steps to the data preparation lifecycle. So that's one of the things I want to get at. And basically, like even though for the typical data scientists, they really see the beginning of their jobs as like, like I put data into my model and basically I train it. It's basically the same thing as to say, like I buy my flour and I basically use this to train my data set, but flour doesn't grow on trees, right? I mean, so basically, if you want to have like high quality like materials or like ingredients for the purpose of baking your cake, you can choose to basically like get your own treadmills and everything and so forth and so on, and eventually build everything from scratch, or you can basically rely on something else. But the important point here is like basically like what seems like raw in the first place, basically like it's actually comes in a raw space, right? And so all of this to basically say that data prep on its own is an entire discipline. It's something that requires lots of steps, and I actually believe that this is something that can be technologically driven and that can be done with machine learning itself, right? And so I'm not going to enter in the details like here nowadays, but technically there are as many steps to data preparation as they are in model preparation, model building, model training, fine-tuning, and so forth and so on. And so it can be really complicated. And the reality is like basically like you don't really get a tool or a process that helps you understand or basically helps you like manage these different steps. And so so this is basically where data prep is going to get there, right? So one of the very important, like for me, blockers nowadays in data prep is viewed as something as is not really scientific and not necessarily something that can be done with a real process in mind, right? I mean, it's like if you look at this little picture here, which you might have seen on social media, right? It's just like people feel it's just like I have to, basically huddle to basically eventually get my data set in a working space, but they don't necessarily see this as being something that can be structured, that can be organized in a nice way and in a scientific way. Anyway, so let's talk about DataPrepOps, right? And so I bet everybody has that question at this point. So basically, what do you really mean by DataPrepOps, right? I mean, so you should get at this point that data prep isn't easy. Data prep can be complicated, can be expensive, can be slow, and it's not necessarily something that's very, well thought out nowadays. Like usually you like to dump your data preparation process to a labeling company, and they may or may not be equipped to do exactly what you need to do, right? And how does this enter at play with MLOps, right? So in order to understand where DataPrepOps sits in the machine learning lifecycle and how it sits with the rest of the data or MLOps, basically a system or process, right? We have to go back to basically understanding the ML lifecycle, right? I mean, so basically when you think about what does it take to build a machine learning model, well, at first, normally, you're gonna get your data, put your data in the right shape. Typically, you're going to have to annotate it and so forth and so on. Then once this data is ready, basically you're good to go, and you're usually ready to start building a model with it. And then when your model is ready, you can deploy this model. And so typically, because you have a feedback loop that can nicely enter into the process, basically all of this should be a cycle, right? After your model gets deployed, you can basically identify model drifts and basically optimize your data, collect additional data, and so forth and so on. And so we all of these different parts of the process are typically pretty complicated. There are many different parts to it and so forth and so on. And so over the last few years, basically because we had to go from that point where we were able to build models to the point where we're able to deploy models, the two parts on the right got increasingly operationalized, right? I mean, so we got lots of companies, lots of open source libraries out there that truly helped us basically efficiently deploy a model, push that model to production. That's what Kubernetes and Docker were created for. And then you have lots of different techniques that were deployed to or invented to basically hyperparameter tune a model, identify the right architecture, and so forth and so on. And we almost took a curse, and basically data preparation is still this old-fashioned kind of slow industry or process and so forth and so on. And we're almost unfortunately, I cannot get started if I don't have a data set that's prepared for me, right? And so this has led us into what I call the data prep oblivion. Basically, we're all basically almost we've accepted the fact that data prep is going to be slow, data prep is going to be boring, data prep is something that really nobody wants to do, or at least that's how we feel, right? And we've almost accepted this, when I truly believe that basically it's time for us to convert data prep into an engineering discipline. So this is really what DataPrepOps is. DataPrepOps is the combination of basically three different elements, right? I mean, so it's basically it starts with the same acknowledgement that we had to go through when we started developing MLOps, right? It's basically the belief that building a model is not the same than deploying this model. So it's just the same way creating a data set is not the same than automating the preparation of this data set and so forth and so on, and basically deploying this and using this as something that's production ready, right? It's also the acknowledgement that basically this can be treated as an engineering discipline and that it has a life cycle, right? Data prep is basically what everybody's used to, right? I mean, so it's essentially the conversion of a raw data set into a training data set. And this is typically something that we see as being low tech, right? Usually this is done by manual labeling, so which is something that's very slow, very tricky, very error prone, and so forth and so on. More recently, you have more and more efforts that have been done towards the development of auto labeling solutions, where basically like you try to use a machine learning model to automatically like annotate your data set. And unfortunately, this is very use case specific, so it's not necessarily like the best way of thinking about the problem. And so I truly believe in the future of data prep in particular is in something I call like agile data labeling. I've written a couple of things on this, so I encourage you to basically look at this later. And finally, it's also like like the acknowledgement that basically like machine learning needs to be data centric, right? I mean, so this is something that has been like a more popularized recently by Andrew Ng and a couple more people, right? So the fundamental acknowledgement that at the end of the day, what we do is called data science and not model science, and data should really be considered as a first citizen in the ML lifecycle, right? If you look at like what different people have said about this in the recent past, right? I mean, so you can, for example, like find Andrej Karpathy from Tesla basically like explicitly say at conferences that basically like it's usually worth much more to spend time on your data set, improving your data set, than trying to improve your model. And so when you combine all of this, you should really like build a data prep lifecycle, a data prep platform, and so forth and so on. So this is exactly what the goal of DataPrepOps is. So this is what my company does right now. So basically, like don't try to read the explanations as you go, because it's probably too far. There are probably many different ways of doing this, but it's basically like the fundamental acknowledgement that basically like you can operationalize, and it does not stop at data labeling. So basically like in the way that we do this, we basically like consider that you have a way to observe how a data set basically impacts the training process of a machine learning model. And basically, like you can, by observing this, you can do like very efficient data curation, identify just the data that matters, that you can basically like operationalize the choice of a data labeling solution, that you can automate the process of auditing a data labeling process, and so forth and so on. And that really everything should be architected as a really like a discipline that can be structured. Right? So anyways, right, I mean, so basically like fundamentally, right, I mean, I think one of the important points here is like really like and so this is where like DataPrepOps can like unlock a lot of really good ideas in the future, is like basically if you go back like to the fundamentals of the preparation, or like basically the building of a machine learning process, we really started with the assumption that basically like everything starts with a data set, which is sort of true, right? But basically that you will be blocked as long as, and basically like you have to sort of like wait for your data set to be ready before you can do the rest. Here, basically, like if you plug in DataPrepOps as like something that's end-to-end automated, that has its own cycle and so forth and so on, it really becomes like basically, I think that's what I put here. It's like basically like it should become like a very important citizen in the data, like the MLOps family. It's like basically like that this piece that if you can automate that part of the process, if you can automate the process of preparation, if you can basically like put in like automated processes to validate the quality of your annotations, to like find the right labeling company, to find the right labeling process, to basically like one of the things we do as well is like versioning of the labels you use, and so forth and so on. If you really do all of this, then everything can become an end-to-end automated, fully operationalized system, and this is the only way you're gonna get to an actual like machine learning life cycle that can be automatically deployed when you don't need to have humans involved, right? So this is like it's really like I want to emphasize like the importance for like the operationalization of data prep, and not necessarily see data prep as being something that needs to be managed by humans, which needs to be like managed by project managers on both sides, from the side of the consumer and the company that's going to prepare the data. And we really need a shift in the paradigm that basically data is not a blocker, data is not a static object. Like in fact, DataPrepOps is also the acknowledgement that you can and you should prepare your data in parallel with your model, and basically have this sort of like a feedback loop, right? And so and that basically like eventually like the way we're gonna get through this and the way we're gonna get better models is not just by acquiring more data, but by being more diligent and more structured with the way we work with our data. So yeah, all right, I'm pretty much done. So yeah, I'm looking forward to hearing your questions.
Thank you very much, Jennifer. Such an interesting talk. I have to say I've really enjoyed the visuals and the figures you presented today. Yeah, really nice storytelling. Yeah. So I guess the audience is taking some time to enter their questions in the Q&A chat. So in the meantime, I can start with a question. So in a conventional ML project, what percentage of resources are usually or is usually allocated to data prep ops? And how will that change once companies start realizing the importance of like the formalization of the data prep ops and yeah, like more or less in an estimate, how will the resource allocation change?
So if you wanna, so first I'll talk about the time, right? I mean, so when you look at like surveys, like statistics that basically like analysts are getting on like the data science community or the machine learning community, typically like people like your typical data scientist or data science team spends like between 60 and 70% of their time preparing data. And that includes like finding the right features, getting your data annotated, like getting, like if you work with synthetic data generation, getting your data synthesized and so forth and so on, like removing like not necessarily like outliers or like anomalies in your data set and so forth and so on. And so this 70% is really due to the fact that everything is sort of done manually, and we all know that, right? I mean, it's like basically the part that's like I have to manually prepare my data set, and this is basically one of the benefits of data prep, right? I mean, so eventually, if you can operationalize that part by including like some of the parts I included in my talk here, basically like we're hoping that instead of wasting 70% of your time manually getting everything done with your data set, you should like basically like be able to get that done like at least most of the parts of it like quasi automatically. To talk about money, right? I mean, so if you are a machine learning first company, let's say an autonomous driving company, a chatbot company, and so forth and so on, the sole part of basically like annotating your data set can cost millions every year, right? I mean, so I think from my own experience, like the average size, like or the like startup like focused on autonomous driving can spend like easily like north of like $1 to $2 million a year on data labeling. Usually they spend like the same sort of like resources on the same amount of money on compute, right? I mean, so this is also an important part, that if you can streamline your data set and you don't need to look at the entire data set because you know which part matters, you will also save on compute, on training time, on storage, and everything else. So it's really an important part in streamlining the machine learning lifecycle.
Thank you, Jennifer. Yeah, so maybe a follow-up question about how is that data prep ops will change the way companies work. How do you see the changes in terms of teams? How teams should be organized? Should there be like new roles, or should people organize in a different way, like in terms of communications or like roles and responsibilities? I know you're passionate about building teams, so like from that perspective, what are your thoughts about that?
No, so first and foremost, right? I mean, so I think it's just like, so by extension of like, I believe there is a shift that will happen for MLOps, generally speaking, anyways, right? I mean, because like as we have like more and more like like the sheer fact that we do have technologies that can automate the deployment of a machine learning model, basically sort of like remove the emphasis for like the need of a DevOps team or a machine learning engineering team and so forth and so on. You're gonna have to have a shift of like, you have more people on staff who can understand the tool than really understand the process, right? I mean, so basically like that shift today is basically happening from like basically like less of a need in DevOps and more of a need in like people who understand Kubernetes, understand Docker, understand containerization, and so forth and so on, right? And so the basically like the coming into the market of like what I call a machine learning engineer or machine learning platform engineer, you're sort of like going to need the same sort of shift where basically like you don't need like people who can basically like scrape into their own data set and do feature engineering and so forth and so on, because you're gonna have companies that can do like automated feature engineering. You're gonna have like feature stores that are gonna help you manage these different things and so forth and so on. So I think eventually the shift is going to go more towards like a data scientist focusing more on like bringing the technology to the next level, bringing the models to the next level, maybe explore new architectures that have not been explored before, right? And so really like going back to research, right? Another important fact is like many companies actually have like for what they consider to be the data preparation operations. So some companies, for example, have like entire teams dedicated to like identifying which part of the data they should be using, finding the right labeling vendor, and so forth and so on. And so more and more so, this is also something that I anticipate is going to be automated by this sort of like solutions out there. And basically like again, like I would like to some extent, like we had this myth of like the data science, like unicorn full stack data scientist that could do everything. We realized this was not feasible because you could not eventually like have somebody who's an expert at the entire stack. I think like we have a shot at like getting closer to the point where you can have like people who can like, because they have tools to assist them, and you have like like most of these processes that are automated that should basically like be more of a like somebody who can like plug and play the different tools together and supervise the entire process.
Right. For sure. Thank you very much, Jennifer, for your thoughts. This was quite an interesting presentation. So I guess the audience can reach out to Jennifer on like LinkedIn or directly on her like contact details. And thank you very much. Please join me on giving a virtual applause to Jennifer.
Thank you. Goodbye. Thanks for listening.
Okay.